Hello, I'm Toby and this is Ruby in the Rough, and today I'm hoping it'll be a nice and short episode. So let me just show you what I'm looking at. Yesterday I found this question on Software Engineering Stack Exchange about whether it's okay to have a method calling another method and that method calling that method. And if you look at this example code, this is actually not good at all, because the reason why it's not good is that you can't follow the flow of execution very easily. So some stuff happens, and then if a condition happens, we jump over to here, we do some stuff, and then we jump back to here and do this again, and then we check this condition which may or may not be true, and we do all this, and if we do, we'll jump back here, and if we don't, then we get to the end, and then we have to jump back to here and keep going with this one, and when this one's finished, then we jump back to there and then finish all this. It's basically, you wouldn't expect anything like that to be, good code. And so I kind of gave an answer down here, mine's right at the bottom there, saying roughly that, and I said the only reason I think of to have two methods call each other is for recursion, and then it's important to make simple and easy to follow. Usually the call the other method, the last thing method does. And then I was lying in bed and I was going through my head, when would you use a method that calls another method? I was trying to think, even in recursion you usually only have one method that calls itself. And then I thought of an example where you would have a method that calls another method, and I thought I'll make it, and I'll add it as a link into this question, in this answer. And I thought I'll let you watch me make it, because it should be nice and short. And here's what it is. Okay, so this is going to be in Ruby. It's going to be saying, is this for that question? And we're going to use recursion to implement quicksort. And quicksort is a way of sorting a list of elements. And what you do is you take one element to be the pivot, and then for all the other elements you go through and you say, if it's smaller, put it in the left bucket, if it's bigger than the pivot, put it in the right bucket. And then you quicksort the left bucket, you join the pivot on the end, and then you quicksort the right bucket and join onto that, and then you have a sorted list. And that's using recursion is a very natural way to implement that if you're not particularly interested in efficiency and speed metrics. But it's a very natural way to implement it, and I thought, well, what if you were, for each level of sorting you did, so you did the pivot and you had your two buckets, and then when you sorted the buckets, you used a slightly different variation of quicksort to sort those buckets. And then as that bucket was being sorted and putting into two smaller buckets, for each of those you go back to the first variation of quicksort to sort those two buckets. And I thought, well, there you would have an example where you'd have the recursion and you have two methods calling each other to do that recursion. So let's implement it. So we have now the difference I'm going to use for the two different variations of quicksort is simply the whether you go from left to right or right to left. So for choosing the pivot, I'm going to use pop in this one. So I'm going to call it quicksort pop. What happened? I'm not used to using. Oh, come on, Atom. I'm not used to using Atom. I'm used to using IntelliJ RubyMine for the Ruby. But I'm going to use Atom today. And then the other way of. So then we're going to pop to get the pivot, and then as we go through putting them into buckets, we'll pop it off the end each time. This one we'll use shift, which is like pop but from the other end of the array. from the start. It takes off the start of the array instead of the end of the array. And we'll have a way to get the list. Okay. A way to okay, so I tell you what we're going to do, we'll make it interesting. Imagine we're sorting penguins by height. Okay. So we get our penguins. To sort, get penguin heights. Give sorted penguins. I'm just going to put in these methods for the input and output, but the main deal is here, the sorting. Okay. To start with, I'm just going to hard code the input. So it's going to be a list of and here I'm going to just like that. It's going to be a list of one. We have some repeats in there as well. Okay. And so what we'll do is we'll so init penguins equals get penguin heights sorted penguins. So we'll just start with the hop. Okay, and then we'll give back the there we go. So right now we're just going to do nothing with them. Okay, that was not even used yet. Okay, so we'll run that. It's good to have something that, okay, that runs, so we can just, if we add to it, we can keep running it and checking what's happening. So what we need to do is to get a pivot. And then come on. I don't like atom as much as until J, I'm afraid. Then we have a pivot. So we're going to, for each let's just do an each. So we're going to have 2 buckets. Let's going to do it like this. Let's call it left. Okay. For each penguin, so if it's penguin is smaller than the pivot, right? Left. Put it in the left. Otherwise, put it in the right. Okay. And then this one just goes through each. I was going to pop them off, wasn't I? I was going to use a nice little pop while yeah, let's go. While there's any penguins, penguins to pop. And put in this line. Okay. So while there's penguins, we pop a penguin, we check it against the pivot. If it's small, we put in the left. If it's big, we put in the right. Then we return the left bucket, but we're going to quick sort the left bucket with quick sort shift left plus the pivot. I'm going to put the pivot in an array to easily concatenate. I'm thinking I'm never good with this sort of syntax. I'm guessing that I can concatenate arrays with a plus. And that returns an array, and so these will each return an array. The thing is to remember when you're doing recursion, you've got to put in a exit case. So that is if there's not enough to sort, that is if there's one or less penguins, then we just give the penguins. Return, give them back as they are. If like that, okay, that's our exit case. Then we essentially do the same thing for this guy, but we're going to use shift instead of pop, and that's the only difference. And that's it. Let's see if it runs. We've sorted them. Let's just make our this is my prompt. This is my prompt for the for the input. Let's reach the heights. Okay. Usually we cut off any new line characters at the end. We get input like that. And then we have to This is really the key part of the prompt, isn't it? Split it by that heights. So we split it into an array of, and then we have to for each height we have to make it into an int. Like that, I believe. And then we'll have a favorite penguin. Favorite. We want to make it random. How do we do random? Oh, I pressed the wrong button. Ruby random int. You just have to use Stack Overflow random.rand. Rand Yeah. My favorite is the one that's this many centimeters tall. Okay. Awesome. Now we got a penguin theme. Do we save it? No. Those are nice penguins. Please tell me each of their heights. 23 centimeters. 7. 13. 4. 32. 8. And 12. Thank you. That's an awesome collection of penguins. By the way, I put them in high order for you. My favorite is the one that's 7 centimeters tall. I'm gonna keep him. And we're done! That's great. So I'm just going to put this on a GitHub gist, and I will link to it from my answer to his question. I'm back because I've just realized I forgot to make the second method call the first method, and that kind of was the whole point of this whole thing in the first place. I really should do that for you in the video. And then again, it shouldn't make any difference. So one of the things about quicksort is that it's known to be slowest when it's trying to sort an already sorted list, and it will operate in like n factorial time for that, whereas an unsorted list will operate in a order n log n time, I think. Don't quote me on those numbers, I'll have to look them up, but that's my feeling. But when we're sorting from each time from the left and then the next time from the right, it means if we're sorting a sorted list, it won't make any difference to the slowness of it. And here we have the final result that's working. Okay, so thanks for watching Ruby in the Rough, and I'll see you next time.